Welcome back to the Further Mechanics 1 videos, Chapter 1.2 Conservation and Momentum. Today we got 5 examples. In our first question we have a particle A and it's got mass 2 kilograms and it's at rest. I'm going to draw it like this. Particle B is another particle and it's got mass 3 kilograms and it's heading towards particle A. So I'll draw it over here, heading towards particle A. It's on a horizontal surface, which we can pretty much always assume, and the two particles collide directly, so they're going to hit each other and then something's going to happen. Before the collision, particle A is at rest. That means its speed is 0. And particle B has speed 3. And we know it's going towards the left, as I say, it's coming towards A. After the collisions, particle A has speed 2. So that means that after the collision, after they hit, the speed of particle A is going to be 2. It's not going to be 2 going that way because A is initially at rest. It can't be hit from the right hand side and then move towards the right. That's breaking the laws of physics. But we know it's got speed 2. And we need to find the velocity of B after the collision. So do we know which way B is going? Well, not entirely. Hence why the question also says state the direction of motion of the particle B. So what I'm going to do is I'm going to call it V. I'm going to do it towards the right. If it's negative, it means it's going the other way. So we're going to use our conservation of momentum. We're going to use this many times in this video. So to say it out in full, 2 times 0, the mass of A times the speed of A, plus the mass of B, which was 3. 3 times the speed of B is 3, but the velocity is minus 3 because it's going towards the left. That's going to be equal to 2 times minus 2, mass of A times minus 2. And we're going to add on 3 times by V. V is positive because I've defined it to be positive. I've made it go towards the right hand side. Well, that's 0. That's minus 9, that's minus 4, and that's 3V. If we add 4 to both sides, and if we divide both sides by 3, we find the velocity of B is minus 5 over 3 meters per second. What's the direction? Well, it's negative. That means we actually got the arrow the wrong way around. So the direction is in the direction BA. So in that direction, B to A, not A to B. And that's it for question 1. In question 2, we've got 2 particles, A and B. I'm not very imaginative with my naming in these questions. Particle A has mass 5 kilograms, and the particle B has mass m kilograms, like this. So this is A, and this is B. They're heading towards each other. So that means that A is moving towards the right and B is moving towards the left. And again, they're on a horizontal surface because that makes the questions work nicely. They're going to hit directly, which makes sense. Otherwise, the maths is going to be completely different. And we're told that before the collision, particle A is traveling with speed 2. So that means I'm going to draw a little arrow up at the top here with speed 2. Particle B is travelling with speed 3. I'm going to draw it like this. I know that B has to be travelling towards A because it says it in the question. They're heading towards each other over here. In this question, the particles coalesce. So that means that after they hit each other, they act as just one big particle. They kind of get glued towards each other. What that means is that they've got the same speed after the collision. We're also told that when the particles combine or coalesce, the particle that's combined has a speed of 1. So that means that, well, we don't actually know the direction. It could be to the right, it could be to the left. I'm going to do it like this for now. But we know that they're both the same. So that's going to be case 1. They're both 1 and they're both going to the right. Alternatively, they're both 1 but they're both going to the left. And again, what you're looking out for is these words speed versus velocity. You don't know if it's left or right. Just because 3 is bigger than 2, it doesn't make a difference. Just like question 1, we set out the usual formula. So we do 2 lots of 5. We do 3 lots of m, but I'm going to do minus because it's going towards the left. And in case 1, it should be 1 lot of 5 plus 1 lot of m. So that's the speed times the mass and the speed times the mass. 2 times 5 is 10. 1 times 5 is 5. I'm going to add 3m to both sides, and we get that m is 5 over 4. So that's one potential value of m. For the second case, we do exactly the same, but now we make sure that the velocity is going towards the left-hand side. 2 times 5 and 3 times m are not going to change at all because we've not changed the initial speeds of the particles. But now we're going to do minus 1 times 5 and minus 1 times m because both of these arrows are going towards the left. Let's now solve this. Let's see what we get. Add 5 to both sides, add 3m to both sides. This time we get m is equal to 7.5 kilograms. So the two values of m, 1.25 or 7.5. And it kind of makes sense that this value should be bigger because then particle B is much massier. It hits particle A and makes it move in that same direction towards the left. In question 3, I've put 3 particles in there. We've got A and we've got B and we've got C. We draw that out. And their masses, we are told, is K, K plus 1 and K plus 2. So I'm going to put that in the middle of each of the circles. They're on a flat horizontal surface and B is between A and C, as you would expect. Particle A is then projected towards particle B, and we're told its speed is 6. That means the speed of A going towards B is 6. Then those two particles are going to collide, and after collision, particle A comes to rest. Because we're not told that B moves originally, we're still told it's at rest. We can make sure that it starts off at 0, but we're told that A comes to rest, so that means that after they collide, A has velocity 0. You can do it towards the left if you want. It's 0, so it won't make a difference. And the velocity of B, we don't know it. Let's call it V. Let's try and find it. In this situation, we can do 6 times by K, that's velocity times by mass, plus 0 times by K plus 1 should be equal to 0 times by K plus V times by K plus 1. So that's velocity times the mass before and velocity times the mass afterwards. These two are both 0, so this tells us that 6K divided by K plus 1 is equal to the speed of B after the first collision. After the first collision, there's another collision between B and C. And we're told that in the second collision, B comes to rest and C has the speed of 2. So I'm going to draw a second diagram for this. We've got the speed of V, which is this, before, and we've got C at rest before the collision. After the collision, B comes to rest, so 0, and we're told that C has speed of 2. And we use exactly the same formula. It's the same formula again and again and again. So we're going to do V lots of K plus 1 mass times by velocity plus 0 is going to be equal to 0 for these two plus 2 lots of K plus 2. V times K plus 1 Well, actually, if I rearrange this, that should be equal to just 6k. So we're told that 6k is equal to 2 times by k plus 2. Let's divide both sides by 2. Let's subtract. And we get this rather lovely answer, k is equal to 1. The question is supposed to say find the value of k, not fin the value of k, but there we go. We have finned it. And in question 4, we've got 2 more particles. We've got A and B. And their masses, in this case, are m for particle A and 2m for particle B. They are moving along the same straight line towards each other. So again, do the arrows like this. One going to the left, one going to the right. They collide directly, which the question is always going to say. And we're told that before the collision, A has speed 8. So I can put that in here. We're also told that particle B has speed 3, so I can put that over here. After the collision, the particles have the same speed. Does it say which direction it's going in? No. In the next part, it also says find the 2 possible values of the speed. So we need to think about 2 directions. So one possible situation is the 2 particles could be travelling at speed v, but opposite from each other. So not together, but opposite each other. So one going towards the left, one going towards the right, but with the same speed. We'll call that case 1. We're going to use the same formula though, it doesn't matter what the case is. I'm going to do the mass times the speed, and then the mass times the speed, again with a negative because it's going towards the left. And that should be equal to minus mv, because again it's going towards the left, plus 2mv. 8m minus, that's going to be 6m, and then minus mv plus 2mv, that's going to be mv. If we cancel the m's, we get this answer that v is actually equal to 2. So that's one possible answer. The other case is if they're both travelling with the same speed, again I call it v, but in the same direction. So it's almost like the previous question where they coalesce, where they're combined together. They're travelling at the same speed in the same direction. We can just treat them as one particle. This is not going to change. The before motion is just completely the same. So in fact, we're just going to write this as, for case 2, just going to straight away write 2m. It's the same calculation as before. Afterwards, we're going to get m times v, and we're going to get 2m times v. And that's going to tell us that 2 is equal to v plus 2v if I cancel out all the m's. So that means 2 is equal to 3v, and therefore v is equal to 2 over 3. So our 2 values of v are 2 and 2/3. You may be thinking, why can't we have the 2 v's going towards the left? Try it out. Work it out using the usual formulas that we've done goodness knows how many times already. See what answer you get for v, and let me know in the comments why it doesn't mean that we get 3 solutions, but we still only get 2. And in my last question, we've got 2 more particles, we've got A and B, and we've got masses 2 and 3. In this situation, it's slightly different. They're connected by a string. And we're told that particle A is projected with speed 5, and it's away from B. That means it's going to be going towards the left in my diagram. One thing to note is your diagrams could have B and A the other way around, and that's fine. As long as it's going away from B in the opposite direction, then the maths will work itself out. In the subsequent motion, the string becomes taut, so that means that the string is loose at the moment, and once A gets moving, it becomes taut, so it becomes tight as a line, and then they move together, and we're told that the combined speed is v. And the speed is going towards the left because particle A is projected towards the left. There's no way that it could be going towards the right if A is projected towards the left. So let's do the maths. Let's do that original formula. We're missing the particle B speed at the start, but it's at rest, so it's not moving, so it's 0. Again, put the 0 towards the left if you want. Now, minus 5 times by 2 plus nothing is going to be equal to minus 2 times v minus 3 times v, making sure that these are all minuses. They do all cancel out each other in the end. We get minus 10 is equal to minus 5v. So we get v is equal to 2 again. If any of those 5 examples aren't clear, be sure to let me know in the comments below. Watch out for the next video where we'll be looking at some past paper questions.